Page 336, number 61, is our application problem for our section on the trig functions of acute angles. In this problem, it states a guy wire, that's a term for a wire that attaches something from the top usually, or if it's not at the top, it'll tell you how far down, to the ground to steady something that's too tall that it might fall over. So a guy wire from the top of the transmission tower at WJBC forms a 75-degree angle with the ground at a 55-foot distance from the base of the tower. How tall is the tower? So you can see that what we have there is a right triangle, and we're given an acute angle of 75 degrees. We're given the adjacent side is 55, and we can use the tower as our opposite side, and I will just label that H, and because the tower makes a right angle with the ground, so we have a right triangle there. So what we want to do is use a trig function that relates the adjacent side and the opposite side and that angle to find H. So the one we're most familiar with is tangent, so I will use tangent. So tangent of 75 degrees is going to equal the side opposite that angle divided by the adjacent side of that angle. So tangent of 75 degrees is going to equal the height of our tower, which is our unknown, divided by the 55 feet, which is how far away the guy wire is attached to the base of the tower. So solving for H, we're going to have 55 times the tangent of 75 degrees is going to equal H. So I'll put that in my calculator, and again making sure that the mode of the calculator is in degrees. When I take 55 times tangent of 75, I get 205.26. So the height of the tower, is 205.26 feet tall.